So here we have 5 problems, and the directions is the same for all of them, and that is to verify this trig identity. So you have to make a decision. Do you want to turn this into that or that into this? You can only manipulate one side, and the other side has to remain untouched. I would rather turn a fraction into regular things instead of making regular things turned into a fraction. So I'm going to try to turn that into that. So I see cosecant, tangent, and secant. These are weird. Usually we like to turn things into sines and cosines instead of tangents and cosecants. So for instance, that is 1 over sine. That is sine over cosine. And this is 1 over cosine. So let's make those changes. So let's see, that is this is that is this. These are just definitions on your cheat sheet. This stays the same, so I leave it empty. Now look, I have a crazy looking thing there, but look, the numerator is a fraction. Fraction plus fraction. To add fractions, you need a common denominator. To make that common denominator, I have to multiply this one by cosine, top and bottom, and this one, I have to multiply by sine, top and bottom. So let's refresh this. So let's see. So cosine times 1 is just cosine, plus sine times sine is sine squared. And the reason the two fractions turned into 1 is because the common denominator was established, which says sine, cosine, and the denominator is just the same thing. Now remember this one thing, fraction divided by fraction, that's weird. Instead of fraction divided by fraction, go fraction times the reciprocal of the bottom fraction. So look, we kept the top fraction the same, but now instead of division, we're going to go multiplication, but that one got turned upside down. And that equal sign is right there. And all of this is invisible, but it's on this side. Now watch what happens. We're multiplication, and this is sine times cosine. There's a cosine up there. These knock out. So all that's left is that over sine. What we can do is we can break up this one fraction into 2 smaller fractions like that. So that's cosine over sine plus sine squared over sine. And look, sine squared over sine, that can reduce. So that the top, instead of sine times sine, is just going to be 1 sine, and the bottom one disappears because it canceled with one of them from the top. And look at what you're left with. You have cosine over sine. That's the definition of cotangent addition. And now the bottom is gone, so really it's just sine. And if you compare it to the right-hand side, look, it's a perfect match. So it's just like check mark, because you change the left over and over and over and over and over until it perfectly equaled the right. Now this one here. So are you going to turn that into that or that into that? Well, you're definitely not going to turn one into that. That would be weird. So let's turn these into a regular looking one. So for instance, secant is 1 over cosine. Cosecant is 1 over sine. Now let's do what we did before. We have 1 divided by this, but you don't want to go 1 divided by that. Instead, go 1 multiplication, the reciprocal. Same thing here. Go 1 multiplication, the reciprocal. That 1 is here, and instead of divide, you multiply, and you turn the denominator upside down. That numerator is there, division turned multiplication, and that fraction turned upside down. And look, those ones knock out, it's just cosine squared plus sine squared equals 1. But in your identities, remember that sine squared plus cosine squared equals 1, and so 1 equals 1. Now for something like this, can you turn this into that? Yes. Can you turn that into that? You can. There's always a way. It just depends on what you want. Personally, I'd rather deal with the fraction and make the fraction go away and turn into things like that. So let me do that. So instead of secant, I'm going to go 1 over cosine. Instead of tangent, I'm going to go sine over cosine. And now here, let's get a common denominator. So what I'm going to do is I'm going to multiply 1 by cosine over cosine. And the reason for that is because then we'll have a common denominator. So that's cosine plus 1, boom, over the common denominator, which is just cosine. And then the main denominator is this fraction, copy and paste, equals, that just falls down. Now let's do that thing again where we're dividing fractions. So let's multiply by the reciprocal. So keep the top fraction the same and multiply by the reciprocal of that. And if you do that, the cosine knocks out the cosine And so we're left with this on top of that. So let's continue up here. Now again, let's do it where we break it up like that and then like that. Cosine over sine, that is the definition of cotangent. And then 1 over sine, that's the definition of cosecant. And if you compare and contrast what we've just created to the original, perfect match. Yes, check that off. So how about this one down here? So right away, I'm just thinking of, I don't want to divide, I want to multiply by reciprocals. So keep that one and then multiply by the reciprocal of that. So that is here. From division to multiplication, turn that upside down. That's invisible there. Now here, instead of secant, let's write that as 1 over cosine and that sine over cosine. And then again, let's go from division to multiplication by reciprocating these denominators. 1 is there, division turned into multiplication. This guy got flipped, boom. Times is still times. And right here, look, 1 over cosine over 1, that one is irrelevant. So really it's just 1 over cosine, and then it's just the 1, so that's not going to change. So honestly, look at what happens. That cosine knocks out that cosine. The only thing that's left in the top is a 1. These ones are totally irrelevant. They can drop off because you're just multiplying by 1. Nothing's going to change. So the top is just 1. And the bottom, the only piece left is sine. But you know, by definition, that 1 over sine is just cosecant. And the right-hand side perfectly matches. So one more. This is probably the toughest one. So are you going to change this into that or that into this? I'm definitely going to take the one that looks uglier and make it look a little less ugly. So I'm going to turn these into that. So let's see. How are you going to add two fractions? You have to have a common denominator. These denominators are not nearly the same. So what you want to do, just put parentheses, what you want to do is multiply this one by that one and multiply that one by this one. So I'm going to multiply this fraction top and bottom by 1 minus sine x. And I'm going to multiply this blue fraction top and bottom by 1 plus sine x. So let's write this down a little prettier. Okay, so this is that, that is this. I just wrote them down a little nicer. Why don't we distribute? And down here, why don't you use the distributive property? Sometimes they call it FOIL, but let's just use the distributive property everywhere. Okay, so you distribute cosine in the top, boom. If you expand this product, that's what you get after you simplify, for sure. So make sure you that bottom, make sure you know how to get that because a couple of pieces cancel in the middle. Up there, distribute, boom. Down here, that's the same as that one. Now notice we have a common denominator. So instead of two fractions, let's add them together into one. And what's really convenient is that in the numerator, if you examine all of the terms, those actually eliminate. And you're left with cosine plus cosine. Well, 1 cosine plus 1 cosine is 2 cosine. And in the denominator, we have that there. Now, what I want to do is I want to take a quick time out and remind you of a very popular identity. Remember that sine squared theta plus cosine squared theta, I'll just call it x, equals 1. This is a very popular identity. And what I want you to see is that what happens if you move the sine squared to this side? What if I subtract sine squared? What if I subtract sine squared from both sides? This would be gone. And this would tell you that cosine squared equals this. But you know why I did this? Because 1 minus sine squared is down here. So what I'm saying is 1 minus sine squared can be replaced by cosine squared. So we're left with 2 cosine over cosine squared. And the reason this is good is because cosine squared in the bottom, that's like cosine times cosine. And either one of the cosines knocks out with the top one. So what are we really left with? We're left with a 2 in the top and a cosine in the bottom. But you know how you can rewrite this? You can write this as 2 times 1 over cosine. Is that right? Right? 2 times 1 over cosine. You can pull out the cosine from the bottom off to the side. And the reason I did that is because 1 over cosine is the definition of secant of x, if you look at your cheat sheet. And so we did all this crazy math and we got 2 secant, and that is exactly what we wanted it to become. We're done.